Folks, hello from Ohio and welcome. So, you want to have the coolest Valentine's Day box in the 4th grade? What can be cooler than a box that plays a fun noise whenever someone puts a Valentine's Day card in your box? Grab your helper and let's learn how to make this together. This time
on Just Making It with Dad.
Folks, this is a fun one that I enjoyed making with my son here. We talked about what we wanted to do for his Valentine's Day box for school, and we came up with this idea here. Why don't you tell us about what it is and how it works?
So this is a Mario warp pipe. There is a sensor inside here that if something goes in, it'll make a sound like a Valentine's card. Listen. Did you hear that? It's a warp pipe.
So it's a fun mixture of simple 3D printing and design, electronics and programming that come together in this little pipe of fun. Let's get started. The parts list for this one, it's not too difficult, though you might want to think about it in advance just to make sure you have everything ordered you're going to need. Let's start with talking about our filament for the printer. I just happen to have some green Hatchbox ABS laying around, but I probably would have gone with PLA if I didn't have that laying around already. Either one would be fine though. At the heart of the electronics is going to be a Teensy 4.1. There are probably various boards you could use such as an ESP32, but I happen to have this Teensy lying around. The key for it was I needed an SD card slot to store my WAV file on. Speaking of which, you'll need a small SD card to store a single file on. Obviously, it won't need to be anything too large in terms of storage. After all, what kind of sound did we have on ours?
A warp pipe sound.
And it was just a couple seconds long, wasn't it?
Yeah.
Next, we're going to need a small speaker. Once again, I'm using this little 1-watt speaker I got off of Adafruit for another project. I'll have a link to it in the description. We'll also need a simple switch to turn our box on and off. Now, to detect when someone puts a card in our box, or what were we using to test it?
My hand.
We're going to need an IR obstacle sensor. The one we're using for our project comes from a Sunfounder kit and works well. There's a detection distance between 3 and 30 centimeters, which can be adjusted via a potentiometer on the top of it. You don't have to use the exact one, obviously. Just make sure that you get one with a similar detection distance and a potentiometer. We'll need that pot to fine-tune how it works and get the distances just right. Now lastly, in terms of parts, we'll need some spare wires of various lengths, some heat shrink tubing, solder, and electrical tape. You did most of the soldering on this, didn't you?
Yeah,
and how old are you?
10.
See, anybody could do this kind of stuff. It's not hard. Give it a try. Now, on the tool front, we're going to need the standard stuff. 3D printer to print everything. I'm using my Ender 3 V2. We'll need a small screwdriver, some soldering iron, a heat gun, and a hot glue gun to help put everything together. Now, as far as software, we'll need a few different things this time around. To design the box itself, we'll use FreeCAD. We'll then use Cura to slice it and print it, but use yours that you're comfortable with. We are going to need the Arduino IDE installed along with the Teensyduino Addon for it, as those are how we program everything onto the Teensy itself. Please note that none of the aforementioned products or manufacturers have sponsored any portion of this video. And once we have all the parts, we can get started designing. You ready to get this started?
Yeah!
Now that we're in FreeCAD, we can go ahead and start creating a simple box. Go to the Part Design workbench and click on here where we create a new body. And in that body, we'll start by creating a new sketch on the XY plane. We're going to add a simple circle to our sketch. And let's give it a radius of 75 millimeters. That's how big the bottom of our pipe is going to be. Since it's green, it's fully constrained, we can go ahead and close this, and we'll come up and give it some height. In this case, we're going to make it 100 millimeters tall. Now we can go in and add a sketch here on the top, and we're actually going to put a pocket into this pipe. So once again, we'll create a circle centered on the origin. I like having 2 millimeter thick walls, so we'll make this a 73 millimeter circle. Again, it's all green and fully constrained, so we'll come down here and close it. And this time we'll choose a pocket. If we want a 2mm base, that means our height on this pocket is going to be 98mm. And with that, the entire bottom is already finished. So we just need to turn it into a mesh by going up to the mesh design workbench, making sure that our pocket's highlighted, creating a mesh from the shape, hit OK. Let's give it a different name. We'll call it pipe bottom. We can right click on that and export our mesh to where we want to save it. Now we need to create the second part. That's going to be the top. So once again, we'll come back up here to the part design workbench. We'll create a new body, create a sketch on the XY plane. I'm going to go ahead and hide this other pipe so it's out of our way while we create this top. And once again, we're going to start by just creating a circle. We're going to build our pipe from the bottom up. This time, we're actually going to have two circles in here. This is going to be the inner circle, and we're going to give it a radius of 76mm. That will allow it some room to fit around our bottom pipe. And then we'll add a second circle outside of that, and this will be the overall diameter of our top. I think we're going to make that 90mm. We'll go ahead and close this out and pad that up. And I think that 5mm should be enough to allow our pipe to sit, the top to sit evenly on the pipe and not fall off, but not be too hard to get on and off. So we'll make that 5mm thick. Now we'll go ahead and add another sketch on top of that one. And this will be the inside. So we need a ledge that will keep this top ring from sliding down all over the pipe. So to do that, we'll once again create two circles. The inner circle we'll make smaller this time. We'll make it 74mm. And once again, we'll want the outer circle to be 90mm. Once those are both green, we can pad this one up. And this will take us to the very top height of our warp pipe. And I think that's going to be a total of 50mm tall. So if we had 5mm on the bottom, we'll add 45mm here to the top. The next thing I think I'm going to do is put a little fillet here on the bottom of this, just to make printing it a little bit easier. So to do that, or use the Make a Fillet tool. So let's come in here and grab our inner line by just clicking on it. And we'll choose Make a Fillet. It's on edge 8 apparently. Remember, that's a 2mm thick wall. If we do 2mm, it will break. So we need to do something slightly less on that fillet. So we'll go 1.95mm, and that should be enough. And you can see it rounds over nicely. So the next thing we need to do is create an inner pipe or spot for our electronics to sit underneath, as well as a slot for our box for the cards and things to go into. So in order to do that, we actually need to create a datum plane. This is we want it on the XY axis, which is good, but it's not high enough. So start by choosing a reference here, and we're going to make that the objects XY. And then we actually want to adjust the placement so it's a little higher. I think I'm going to adjust it so it's about 37mm up from the bottom, and that's where we will build our top inner portion. And you can see that that raises it up, and now we have a plane on which we can actually build. So we'll select this datum plane, and we're going to create a sketch on it. And once again, we'll just start with a circle for this first one. So we'll come in here and create our circle. We know that we want its inside dimensions to be the exact same as the inside dimension of that bigger ring. So we'll change its radius to 74mm. And we're also going to want to carve out of this their slot. So if we come in here, we'll draw a rectangle, and I like to center it first around the origin. Well, if I can get everything unselected. There we go. So if we grab opposite corners while holding down the control key and then select the origin and hit the S key, that will actually center it around the origin. Now we can add a vertical constraint, which I think will make 20 millimeters, and a horizontal constraint of 110 millimeters. Now you can see that everything is green and constrained fully to our sketch. We have our slot where everything will go. So now we just need to pad this sketch up 2 millimeters. And there we have it. We have the top that will sit right down on top of our warp pipe bottom. So all we need to do is make it printable by going into the mesh design workbench and create a mesh from shape. We'll give it a different name. We'll call this pipe top. And we're ready to right click and choose export our mesh. We'll save our meshes and then we're ready to get everything printed. Once you open your slicer, you can open up both the warp pipe top and the pipe bottom. I've got the pipe top here because it's the only one that needs a little bit of thought in how we slice it. The pipe bottom, it needs absolutely no supports. It's nothing fancy to actually do. On the pipe top, you will need a support because, as you can see from underneath, the entire top ring here that's in red is pretty far away from the build plate. And if you try to print it like this, it just won't work. So I have been a real fan of the tree supports here in Cura lately. You can set your overhang angle relatively high. You don't need to worry about that fillet down there at the bottom that we have, trying to remove that material. It's really this material here that's going to be the most important. But once you add that support, you're ready to slice and get printed. Now, in addition to printing out the parts we designed, we're also going to need a battery holder big enough to hold and wire together 3 AA batteries. You could try to make one yourself, but I'm a big fan of the ones created by user enif or enif, I'm not sure how you pronounce it, over on Thingiverse. I use them on a couple of different projects now. I'd encourage you to go check them out before you do it on your own. Just follow the link in the description. So Jackson, we're going to show all of the printing, everything being printed now. Do you always like those time-lapse videos?
Yeah.
How about the song we made for this one?
I can't wait to hear it.
We're going to get started by setting up our Teensy and getting it programmed. In order to install the program that will run everything, we need to open up our Arduino IDE. Make sure that you have saved a copy of the Arduino Teensy sketch that I have provided on my GitHub page to your computer, and then we'll open it up. So let's start by getting rid of everything in here to begin with, and then we'll open up our recent sketch. Everything should work out of the box if you've wired it the way that I've wired it and you're using a Teensy 4.1. Make sure before you do anything that your board is set to Teensy 4.1. Plug it in, the Teensy, into your computer using a USB cable that will actually do data. If for some reason you can't get it to recognize your computer, to recognize the board, try swapping out your cable. I found that some cables that come with some phones, for example, only do charging and they won't actually pass data. We need one that passes data. Once you have your Teensy connected, you'll simply upload the sketch to your Teensy. You'll need to wait a moment while it's compiling the sketch here. Once it's finished compiling the sketch, you'll hear your USB, if you have your sound on, the noise as it's disconnected and reconnecting, and you'll see that it says done uploading. At this point, your Teensy has everything on it that it needs. The only other thing you'll need to do is put your WAV file onto your SD card and put it in your Teensy. The WAV file that you want to use should be called warppipe.wav, and it will be in all uppercase. You can either change the name here if you want to use a different WAV file, or just make sure that you name your WAV file the exact same thing. Now we need to set up and wire a battery holder. Because we need 4.5 to 5 volts for our Teensy, the IR sensor, and the speaker, we'll need to wire our batteries in series. You remember what the opposite of series was?
Parallel.
So take a few lengths of wire, wrap the bare wire around the positive end of the battery compartments, and connect it to the negative end of the next compartment over. It helps if you use rather long pieces of wire that have a lot of the outer cover stripped off of the end. This will allow you to make several wraps around the inside for your battery connect with. Repeat that process again for the next set of batteries. Then add a lead wire coming out of the positive and negative terminals on opposite ends of the compartment. These will then connect all of the other electronics. Now it's time to start soldering some wires together. Who did most of the soldering on this?
Me.
From the negative side, we come up and into this junction right here that combines 3 wires coming out of it. Each one goes to the ground side of both the IR sensor, the Teensy, and the ground of our speaker. Coming out of the positive side of our battery compartment, we come into this switch here. From there, we come over to this junction here where once again we have 3 wires coming out of it. This one is the voltage into the IR sensor, the voltage into the speaker, and to the voltage in on our Teensy. Last up, we just need to go from pin 12 of our Teensy to the signal on the speaker, and from pin 29 on the Teensy over to the signal on the IR sensor. So as you can see, the electronics really aren't all that complicated. We have a battery compartment here that we printed and hot glued into place. Our Teensy is over here, just held in place with some electrical tape because we weren't going to be using this on a permanent basis just for the one day. We have our IR sensor right here. It's also just hot glued in place at the corners. Our small speaker, also just hot glued in place at the corners, and a switch just to turn everything on and off. When you're putting in your IR sensor, make sure that you have it back away from the edge just a little bit. After that, what we need to do is fine-tune that potentiometer on the top of the IR sensor. Using a small screwdriver, you want to adjust the potentiometer so that it's constantly making sounds as if something was blocking it. Then, what we do is we turn the potentiometer the other way just until it stops making noise. That has the effect of calibrating it so that it senses when the car goes by. This was a fun little project. It's a nice combination of simple 3D design and printing, some simple programming, and simple electronics. What's really nice is it's a good introductory type project for the kiddos. Mine did most of the soldering on this project, as it's pretty straightforward. While I made a warp pipe, you can come up with any combination of box and sounds using the general approach outlined in this video. We really hope that you enjoyed this project and that you like this video and subscribe. If you make your own variation on this, I hope you'll describe it in the comments, and I look forward to seeing you in the next video.